Hello everyone. This lecture is about neutralization. We are continuing our previous with the previous concept that we have discussed was about acid and bases, and we have talked about different definitions. We have seen that what are the different concepts about acids and bases. So acids and bases, as a general terms, they are not um, uh, unfamiliar to you. So in our kitchen, in our household, in our cosmetics, we are using some of the products which have either the acidic nature or either the basic nature. So on chemical side and a more technical side, we have defined that what are the different definitions, Bronson and Arrhenius and the Lewis, how we can define the acids and the bases. And we have seen that some acids are the strong and some are the weak. And this is the same for the bases one. So the bases can be strong and the weaker one. Now we will talk about another concept. This is the neutralization, which is the extended point and the discussion of the acid and bases. So whenever we are discussing about the acids and bases, so there is the term neutralization comes. So we will see how we can define the neutralization and what the neutralization gives us as a product. So moving towards our slides. So by definition, a neutralization is a reaction or the phenomena, or this is a term we use when we are mixing, we are reacting an acid and a base together. Or you can say when the solutions of an acid and base are combined, so we get the products, we get water as a product and we get a salt of it, because whenever the acid is reacting with a base, it gives us the water and a salt of the combination of the acids and the bases. So the equation, the chemical equation, we can write as molecular, complete ionic or net ionic form. So I will explain you that what the molecular equation is, what the complete ionic equation is, and what does we mean the net ionic equation. So as we most of this course students are the non-major and they are not the chemistry students, so they may have the general perspective. So for their convenience, I have to refresh that what is the equation is. So equation is a mathematical form or mathematical expression to define, to explain the chemical reaction, what is going on. So we mention the reactants, what are the different um, competing, what are the different reacting species which are combining, and what is the output, what is the overall product out of that reaction. So in an equation, we also mention the exact moles, that how many moles of a reactant are combining with the second reactant and they will give the product. So an equation is giving us the complete information about how many grams and how many moles of uh, reaction are coming as a product one. So this equation needs to be balanced from the both side. So there is a one side which is a left one. It is giving you the idea about the reactants which are participating in it, and this end what is on the right side, this is a forward side. This is giving you the information about the product one. So we can see here that the general form of the general form of this reaction is that whenever there is a base, right, this is reacting with an acid. So this arrow is basically giving you the direction of the reaction, that these are the reactants and they are combining with, they are moving forward to convert into the product. So this right side is basically giving you the information of the product one. So if there is any of the reaction in which you see the two-sided arrows, so the half arrow on this side and half arrow on the backward side, So that kind of reactions are the reversible reactions, means they are equally moving on a forward reaction, and similarly the products are reconverting, or they are um, again coming back to in their original form, and they are giving you the reactants back. So they are the reversible reaction, but right now we are just writing the forward reaction, and this is called chemical terminology, this is the irreversible reaction, right? So the general, in a general reaction, when you want to explain that what the neutralization is, the neutralization is when the acid and bases, they are combining and they are giving you the salt and a water as a product. So now if we chemically exactly what are the two chemicals we are mixing together, so for this we have to mention their molecular formula, right? And then we will write in an exact equation, and we will write the exact products which we are getting from that participating and the reacting species. So right now, here in this equation, this is the HCl, this is the hydrochloric acid. So you have learned about the HCl. This is the compound which is formed by the ionic bonding, and when we have covered the ionic and the covalent bonding lectures in which we were talking about the bondings, so you are familiar with the HCl, right? And HCl is also produced in our stomach for the digestion of food, and the sodium hydroxide is also another reactant, and this is the base because it is the hydroxyl giving species, and the HCl is basically the molecule which can give the H positive ion in the reaction system. So now these are the HCl and the sodium hydroxide which will combine together, and now we will see that uh, through the arrow we are giving the information that this reaction is moving forward, and this is an irreversible reaction, and now we are getting the water and NaCl, which is the sodium chloride, as a product. So sodium chloride is also very familiar and very common compound, and this is called as the table salt, the salt you are using in your daily life. This is the sodium chloride chemically. So sodium hydroxide you may have familiar if you are very much curious about the compositions of the cosmetics and other things you are using. So you may have seen that most of your soaps do contain the sodium hydroxides. They can be prepared from that one, because then from the glycerol we can combine with the sodium hydroxide, and then this is a caustic soda basically, so they can get and convert the glycerol or glyceraldehydes into the soap. So here, this is the HCl, sodium hydroxide, and water and NaCl. So I need your focus that you should familiar with the some of the terminologies if we are mentioning in writing the equation. So what does it mean? So right now in HCl, we can see that in the small brackets there is the AQ. So aqueous, this is the abbreviation of the aqueous, AQUEOUS. Aqueous solution means that this is the HCl which is dissolved in the water. So this is the diluted solution of the HCl. We are not directly using the HCl and sodium hydroxide in the 100% concentration because they are very strong. So then that will be not manageable for us to see that what are the products are. So they are the very dried product we will get. So right now we are using the solution. So then the sodium chloride will be dissolved in that aqueous solution. So here the HCl in aqueous solution, this is a solution of HCl, this is a solution of sodium hydroxide. We are combining these two and we are getting the product, and L is mentioning that this product is in a liquid state. This is a physical state, like what in a what physical state our compound would be. We have seen the states in the matter under the topic matters. when we have discussed that what are the different states of the matter. So the water is liquid in physical state, and the sodium chloride is right now, otherwise this is the solid one, but right now, as we have the water in our medium, and the sodium chloride is very soluble in the aqueous solution, so this is in an aqueous form. So this equation is basically known as the molecular equation. So in which we are mentioning completely the molecules with their number of moles and exact molecular weights. So mentioning the products. So this is the molecular equation. So here, if you just focus, so HCl, if there is no numeral before any of the molecule, so then it means this is only the 1 mole. If there will be the 2 in front of the HCl, so then it means there are the 2 moles of the HCl which are participating for this reaction. So right now this is 1:1 reaction. So 1 mole of HCl is reacting with the 1 mole of sodium hydroxide to give you the 1 mole of water molecule and 1 mole of sodium chloride, right? So we will talk about more in details about the moles. So mole is basically the way to express that how many grams of the molecular weight of a compound is participating in a reaction, right? So there is the 1 mole of HCl is combining with the 1 mole of sodium hydroxide, because sodium hydroxide is able to donate only one hydroxyl per molecule, and same is for the HCl. So there is no other ratio, so they can neutralize each other with the 1:1. So now we will go for the complete ionic equation. So in complete ionic equation, what we do is that what are the molecules which can have the charges, and we write them in their dissociable form, right? So there is the H and Cl, and we know this is the ionic bond. So Cl is the negatively charged and H is in the positively charged. So H positive plus Cl negative, then sodium plus N plus OH, because in that form that molecule will uh, will be broken, and then it will convert into the product. So right now we are writing in their dissociate or in their ionized form. So here, this OH is combining with this hydrogen to give you the water molecule. So water we will write is as such, because this is the liquid which is present in this reaction system, and this has combined because whenever there is a hydroxyl and H positive, they straightly form their the neutral molecule, which is the water. Now, in this case, we are getting the salt, and salt is again in the ionic form, because the Cl is the negatively charged and the sodium is in the positive charge, right? So we will write their dissociated form, or we will write them in their ionized form. So now we will see this is the complete ionic equation, in which we were writing all of the molecules on the reactant side and in the product side in their ionizable form. Now if you just work on something, like if you just focus on for getting the net equation, so what we can do is that we have to separate these, that what are moving here. Yes. So let's see which are the available in both sides. We will cancel these ions or ionic species. So let's say this is a Cl negative and it is present at in the left side, and this is present on the right side also. So we can cancel these, because when they are moving to the other side of the equation, so they will change in their sign. If this is in, there is a P and there will be a positive, and then it will go to the other side with the negative sign, so they will cancel each other. So we can cancel from the both side of the equation. Now the sodium is again, this is present on the left side, and sodium positive is present on the right side too. So these both charges and ions have cancelled each other, and now we left with H positive, OH negative, and the overall is the water molecule, right? So the net equation will be, so our net equation is basically, so our net equation is H positive and OH negative and overall the water molecule. So net equation is basically the equation which is giving us the information about only about the charges which are directly involved for the reaction. So basically when the acids and the bases are participating, so the charges which are involved in directly in the reaction is the H positive and OH negative in the aqueous medium. So this is H positive and OH negative. The H positive is coming from the acidic species, which is donating hydrogen ion, and OH negative is coming from the base one. So then they are combining and they are converting and they are giving the water molecule. So other species which were the part of these base and the acids, so definitely they are the leftovers of these one and they will combine in the form of the salt, another neutral molecule. But the most concerned and the active and the directly involved ions are the H positive and OH negative. So whatever the net ions which are involved in a chemical reaction, after cancelling the common ions from both sides of the equation, this will give you the information about the net equation. So now we will see diagrammatically that how this has formed and what we will get when we are mixing the two test tubes. In a one test tube, there is an acid solution, and right now we are discussing the example of HCl and the sodium hydroxide. So in the base test tube, there is the base. I have mentioned these with the blue and the red color intentionally to explain, so that will be more understandable for you, because acid, you know, that these are at the reddish side on the pH scale, and they turn the blue litmus paper into the red, and the base is the solution of that molecule which turns the red litmus paper into the blue, and on the pH scale also they are more towards the bluish color, which is mentioned for giving you the idea about the pH on the pH scale. So pH scale is basic for the which is giving you the information about what is the pH of your solution from 1 up to 14, and we know this is a pH, yellow pH paper, which we use in our laboratories to see that what is the pH of our given solution. So now we will see that we are combining these two test tubes, and here through the reaction we will get the product salt plus water, and the salt in that case is a sodium chloride and the water. Now an interesting thing is that what happens when we neutralize the acid with a base or vice versa. So basically what is happening that in an acidic solution, this its pH was the acidic side. So that may be the 3 or the 4 or maybe the 2 1, depending on that what is the concentration of this one. But HCl is a very strong acid, so it usually is at 3 and 2, right? And sometimes it goes to the 1 as well. So the base sodium hydroxide solution pH is around 12 and 13, right? So when we are combining these one, so chemically this is giving you the product water and the salt. It means if that has completely neutralized, neutralize means to nullify, to cancel each other's effect, right? So the salt is a neutral, the water is a neutral molecule. So what should be the pH of that solution? So definitely, if this is not acidic, if it is not basic one, so this is in between that one, and they both have canceled each other. In fact, they have neutralized each other. So the pH which will be shown on the pH paper will be the 7, and the 7 is the neutral pH. This is the central point of this pH scale. The solutions which are not acidic one, which are not the basic one, so they are completely neutralized, or the neutral solution, so they give the green color on the pH paper, and this is showing the 7 pH, right? Though there is a little bit shade difference in this one, but this is basically to mention you that this is towards the neutral side of the pH. Now we will go for the nature of the salt. So because there are the different kind of acids and the bases combinations we can use, so nature of salts will definitely come up with the reacting acids and the bases one. So there are the three kinds of salts we can get after the neutralization or the neutralization reactions when we are mixing the different acids with the different bases. So let's see. One, the first case is if a strong acid like HCl is reacting with the strong base, which is sodium hydroxide, then the salt nature will be neutral because they both are strong. So they both are have the equal tendency to keep cancel each other. So there is not no there will be not any prominent nature or characteristic of acid or the basis one. So no one is dominating the salt nature. So it means the salt is at the neutral side. So if the B case is if a strong acid and a weak base react, then the formed salt is the acidic one because the dominating part was or the reactant was the strong acid one. So take was an example that if we are reacting with the HCl with the sodium acetate or some other weak base, so then the formed salt will be acidic in nature because then that can easily dissociate in and that can liberate the hydrogen ions in the solution system. The C one is if we are using the strong base and a weak acid, so the resulting salt will be the basic in nature. So when you will test, you will make their solutions of all these three kinds of salts. So you can compare their pH that if you have mixed the strong acid with the strong base, so the salt solution was the neutral one. And when you have neutralized the strong acid with the weak base, so then the formed salt is showing somehow the acidic pH. And the third case is when the strong base was reacted or combined and it was neutralized with the weak acid. So then the resulted salt solution is showing the basic nature on the pH paper. Now we'll go for the applications of the neutralization, that what is the importance and the significance of that neutralization. So it has a very wide spectrum in our applications, in our industry, in our household, in our daily routine. So some of the most common and the famous one I have listed here. So the neutralization method is used in waste water treatment because there is a certain pH which we require for the drinking water, for the watering, for the water for the plantation. So that has to be treated because if we the effluents, the industrial effluents, some are releasing the very acidic water in the stream, in the rivers, and the some are effluents are very basic ones. So before releasing or before discarding this water into the outsource, into the um, side where they can mix with the fresh water, so they has to be treated for their pH. So they have to neutralize, so the effluents are neutralized with the treatment of acid or bases, depending on at what kind of effluents we are releasing in our streams, in our rivers and the oceans. So the second is in the manufacturing of antacid tablets. So many of us are very have a very common issue with the acidity and the heartburning. So these are type of drugs which are developed for treating that heartburn and that acidity are called antacids. So antacids are basically basic in nature because this is happening usually because of the high amount of acid in our stomach. So I will talk about in detail in the next slides. This is also neutralization phenomena, and this reaction is also useful in agriculture purpose for treatment of soil. This is also to resolve our different health issues, and this is also very useful in our food industry for the quality, for maintaining the quality of our food for the longer time to increase their shelf life. So we will see one by one. The first is the tooth decay or cavities. So basically the chocolates and decaying food particles when we eat, so we chew in through our teeth, and they are basically um, grinded. They are basically responsible for grinding and chewing the food, and due to that decay, the food is basically reacting with our mouth enamel, and this is producing the acid. So that enamel is basically calcium phosphate in nature, and when it is combined or reacted with the acid one, so this is deteriorating its structure, so that definitely our enamel is destroying and lead to cavities. So this is creating the gap. So usually using toothpaste while brushing help to neutralize the acid, since toothpaste is a base. So when if you just look at the composition of this one, so they have the sodium and potassium salts and the compounds for giving this the basic pH, because then it can treat us or tooth for from the acidic one to the neutralized pH. So that's why we don't have the damage of our tooth, right? Because this is a calcium one. So if we are using the very high acidic content, so that will um, removing, and this is destroying its structure. So the next one is to treat acidic gas. In most of the industry, like the power stations, burns fossil fuels such as coal to produce electricity. The burning fossil fuels will liberate sulfur dioxide, and these oxides are basically acidic in nature. So they cause the pollution in air due to their acidic nature. Hence, the power stations treat this acidic gas using powder lime. So the lime solution is called the calcium oxide, and there is another one is the limestone. These are the common names of these one. So chemically, this is the calcium carbonate. So basically, what is happening that these power stations are passing this acidic gas through the powdered lime, calcium oxide, or the calcium carbonate to neutralize it, because when it passed through this one, so this get neutralized from its surface, and then it is not the acidic gas which we are liberating in the air. So that is uh, preventing from the air pollutant, which could be the damaging for the building, and they can cause the acid rain. The third one is the gastric patients. So as I have talked about antacids earlier in previous slides, so basically the antacids or the antacids are the medicines containing bases such as sodium bicarbonate and the magnesium hydroxide. So magnesium hydroxide neutralize excess of acid in stomach. So there are the number of causes we are having the high acidic content in our stomach. That is due to the acidic food we are consuming. That is due to the high amount of HCl, which is a secretion in our stomach to digest the proteins, especially, and to break down their peptide bond. So that's why this is released. But sometimes this HCl is releasing in high content, in an abnormal content, rather than an our normal concentration. So then it causes the heartburn because this is damaging the stomach lining also. So then these kind of medicines and the tablets, they are also available in the form of the sachets, which can be taken by dissolving in the water. So these antacids are curing and treating these heartburns which are due to the HCl. So basically, chemically, what is happening that these antacids are neutralizing at the pH of the stomach by reacting with that one. Now, the next one is to treat the wasp stings. So, wasp stings are basic in nature. So, it is a very common remedy also that you can use your vinegar, which is already available in your kitchen, for treating if you have got the wasp sting. So, the vinegar is acetic acid chemically, and it used to cure wasp sting as it neutralized the stings because these stings are basically basic in nature. So when they neutralize, so they just nullify its effect, and then it release the pain and the burning you are feeling after the sting. Some of the home uses are we use the baking powder, which is basic in nature and that help in many of our baking purposes. So it is basically the sodium bicarbonate and a weak acid. When the water is added, both water and the sodium bicarbonate react. So the reaction is like an acid acting on a carbonate. So this gives out carbon dioxide, which raises the cake. So basically, the small, the basically the structure at which there is a swelling. You have seen that the cake batter is basically pop out. So this is because of the carbon dioxide which is released by reaction of that baking powder with the water content. So if we use in a dry form, so that would not happen. So for this, you have to use some of the moisture and a little bit of the liquid with that, so that sodium bicarbonate is dissolved in it, and that can act on that baking purpose to enhance the batter for its form, to make it the most soft texture which you can use for the baking purpose. Now the last one is a shampoo. So shampoos are mild alkaline which cause small scales on each hair, which make your hair unmanageable. So to solve the problem, we use the hair conditioner. Hair conditioner are mild acidic one. So when you use the acidity in the hair conditioners will neutralize the alkali and cause the scales to close up. So basically, we are once we are shampooing our hair, so we are giving some of the basic, because most of the surfactants are the basic in nature. So there is the need that we should condition our hairs to neutralize the pH of hair, because at a very high acidic, or at a very high basic pH, so that structure, hair structure, can be damaged, because we know the hairs are made up of the proteins. So the proteins are very sensitive to the pH. Now the task at this end of this lecture is this one, that I have given you another example of the two reactants. So sodium hydroxide is there, acetic acid is there. This is the acetic acid, this is a sodium hydroxide. They are reacting together, and we are coming up again the water and the salt of it. So this is a sodium acetate, is a salt we are getting in this equation. So you have to write its net ionic equation. I have mentioned its ionic equation also, the complete ionic equation, after the writing the ionized form of the sodium hydroxide and the acetic acid for your convenience. So you just have to tell the what would be the net equation, ionic equation of that reaction when the sodium hydroxide is reacting with the acetic acid. I hope you got that concept of the neutralization, but if you still have any questions, so you are very welcome to comment and to ask your queries. So I would love to answer you. Thank you so much. Have a good day.